Lesson 82, algebraic simplifications. This lesson is going to look very similar to something that we have already done. It's just kind of a nice review lesson. But just to start off with, and I'm not going to make you write any of this down until we get to some of the examples, but in algebra, there are three basic rules that we implement most of the time in solving equations. Two of these rules aren't used unless we have an equal sign in them. So those would only apply in which we're solving for a variable in equation. Those rules would be you can add the same number to both sides of an equation without changing the solution. Okay? In other words, what you do to one side, you have to do to the other. And the second one would be every term on the equation can be multiplied by the same number on both sides of the equation without changing the solution. All right, those two we deal with in solving equations, but this last one, some people call it the denominator-numerator rule, but this one is used on individual terms, not necessarily in an equation, but they can be used in algebraic expressions, which would be something without an equal sign. And this one would state that the denominator and numerator of any expression can be multiplied by the same number without changing the value of the expression. Essentially, we're simplifying equations by using these algebraic rules. All right, so these are going to look very similar. We're going to work through a couple together, and then I'm going to have you do a couple by yourself, just in review. All right, so the first one, these are just problems. The first one looks like this. All right, we have a over 1 plus a over 1 plus 1 over x. All right, I know you guys absolutely adore these problems. All right, so you get a whole lesson to review them. All right, so first of all, what we want to start with is simplifying. Obviously, we're simplifying the equation, but we want to start with the most intricate part. So let's first of all start with this denominator. We want to simplify the denominator 1 plus 1 over x, and we're going to do this by finding a common denominator. All right, our common denominator is going to be x, and our numerator becomes x plus 1. All right, so we have x plus 1 all over x. All right, so now our equation looks like this. We have a over 1 plus a over x plus 1 over x. All right, the next thing that we want to simplify is this term here so that we can add it to the 1. In order to simplify that, we're going to do a over 1 times the reciprocal of x plus 1 over x, which would be x over x plus 1. All right, so when I multiply this through, I'm going to get ax over x plus 1. All right, so my new equation now looks like this. I have a over 1 plus ax over x plus 1. All right, the next thing that we want to do is we want to simplify this denominator term, all right, by finding a common denominator. All right, so I'm finding a common denominator between 1 and x plus 1, which is going to give me x plus 1. All right, the new numerator for my first term is going to be x plus 1 plus ax. All right, so that is my entire new numerator. Okay, so now my equation reads a over x plus 1 plus ax all over x plus 1. And to simplify this finally, we are going to multiply a over 1 by the reciprocal of x plus 1 plus ax over x plus 1. All right, we're going to go ahead and use the distributive property. A times x gives me ax. A times 1 gives me a. So my solution is ax plus a over x plus 1 plus ax. All right, and that is the final simplified term. All right, so we're just going through and we're simplifying these problems algebraically. All right, let's work through one more together before I have you do one by yourself, just in review. All right, we have b over a plus c over x plus 1 over y. All right, I don't know if this one will be harder or easier because we have all different variables, but we'll see. All right, the first thing that we want to do again, is we want to simplify this denominator term by finding a common denominator. All right, so my common denominator here is going to be y, and the new numerator is going to be xy plus 1. All right, so now my equation looks like this. I have b over a plus c over xy plus 1 over y. All right, the next thing that we want to do is we want to simplify this whole term so that we can add it to a. All right, so this is a division problem. We're doing c over 1 divided by xy plus 1 over y, which means we're really multiplying by its reciprocal. All right, so that's going to give me cy over xy plus 1. All right, so my equation now looks like this. I have b over a plus cy over xy plus 1. All right, so the next thing that we want to do is simplify this denominator so that we can divide. And we do that by finding a common denominator. Common denominator in this case would be xy plus 1. All right, the new numerator for my first term is going to be axy plus a, and then plus cy. All right, because I multiplied xy plus 1 times a, so I distribute it through to both sides. All right, so now my equation looks like this. I have b over axy plus a plus cy all over xy plus 1. All right, so the last thing to do would be to divide. All right, so I'm going to do b over 1 times the reciprocal, so times xy plus 1 all over axy plus a plus cy. When I distribute in the numerator, I'm going to get b xy plus b all over axy plus a plus cy, and that is my final simplified term. Okay. All right, I'm going to put 2 more on the board. I want you to go ahead and try to work these on your own tonight. If you need to go back and rewatch these last 2 problems, go ahead and do that. All right, but the last 2 that I want you to do on your own, I want you to do 1 over 3 plus x over 3 plus 3 over a. Go ahead and try that one. And then I'd also like you to do m over x plus p over q plus 1 over z. All right, so go ahead and try those 2 on your own. We'll come back and we'll take a look at these in class.